Here comes the sky.
It's that time of year. Not just the time to talk about oscillations and simple harmonic motion, but it is that time of year when you are done with school and you're ready to just start summer already. Maybe you're near spring break, whatever it is. Take a deep breath, relax. I know the previous units are life draining. Angular momentum, anything dealing with those circles are really difficult. That doesn't mean you should give up on them and say, because in all likelihood, you're probably going to get free response question on rotational motion. But the good news is this unit is pretty easy and enjoyable. So fall back in love with physics. That's what we're working on with this one. Starting with oscillations. How do we describe an object's motion if an object's motion repeats? By the end of this lesson, we're going to be able to define oscillation, periodic motion, and simple harmonic motion, and be able to experimentally determine when an object's motion can be classified as one or more of these. We're going to be able to predict the motion of a mass connected to a spring or a mass connected to the end of a string. And finally, we're going to be able to experimentally determine the spring constant of a spring. The vocabulary we are going to be dealing with throughout this lesson will be oscillation, which is any type of motion that repeats between two endpoints. A synonym for oscillation is periodic motion or harmonic motion. Simple harmonic motion is a special type of oscillation that has properties that make it the easiest periodic motion to analyze and describe. So we like simple, right? Equilibrium is the location where an oscillating object experiences no net force. That's where all of your forces are balanced. The end point are two locations which serve as ends of the oscillating object's motion, also known as the amplitude. And the amplitude is the distance between the oscillating object's equilibrium point and one of the endpoint. It'll make sense soon. Amplitude measured in meters. We have restoring force, a title given to whichever force or combination of forces acting on an oscillating object that is directed toward the object's equilibrium position. Restoring force is kind of like centripetal force and net force. It's not a new type of force. It is a descriptive title we give to that force, whether it's weight, normal force, friction, and so on, that is directed towards the equilibrium. Period is the time it takes for an oscillating object to repeat its motion. Symbol capital T, units, seconds. If we have period, we're also going to be talking about frequency, which is the inverse of the period, and that is the number of cycles that an oscillating object completes in 1 second. Symbol lowercase f, and the unit is a cycle per second, known as the Hertz, after Heinrich Hertz. And remember, period and frequency are reciprocals, so f equals the inverse of the period, and period equals the inverse of frequency. We also have angular frequency, which is the number of radians a cycle of an object completes in a second. There are 2 pi radians in one full cycle. Remember, the symbol is omega. The units are radians per second. Basic equation is omega equals 2 pi over the period and 2 pi times frequency. That's a typo, because frequency is 1 over